This episode of the Amp Hour is brought to you by viadesigner.com, part of Triad Semiconductor. Who needs a chip printer when you can design your own mixed-signal chips on your desktop? Via Designer is a Windows-based software for the design and simulation of analog and digital circuits. At viadesigner.com, you can learn about mixed-signal design, share your design IP, and form teams to create your own custom VIA ASICs. Go to viadesigner.com/theamphour and enter coupon code AMP100 at registration for a free year of Via Designer, a $500 value. This is the Amp Hour podcast, recorded April 15th, 2013. Episode 141, Wampums, Wavering, Worth.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
You're not going to believe it, Chris.
What's that, Dave?
I can see the floor of my lab.
No way. It's clean,
yeah.
Huh? Who'd you pay? Who did you hire?
It's novel. I hired the wife, and she came over and on the weekend. You need to clean up that pigsty. Yes, dear. All right, so she and
so what, she directed
Sagan,
you, or
yeah,
I picked that
and
up.
they both came over and we attempted. It took us several hours, and we could at least see some floor now.
Wow,
which is incredible.
Wow!
Because if you haven't seen my photos, like this lab is an absolute pigsty. To get from the door to my bench where I film, I've actually got to step over 10 things. You know, it's
definitely needs shelving
or
something.
Yeah, it's
like
disgusting.
Big
but there's still shit
shelving
all along the floor, along my bench. But at least the main area is clean. And yeah.
Oh yeah. I mean, look, my bench here. I mean, when I moved in, this whole basement was barren, and now it's just completely
filled with crap.
Full of crap. Yeah. So much stuff. Oh, it's okay. I don't need to throw it out yet. You know how that gets, right? It's like
yeah. And then we complain about it every time, don't we? Like, I can't. Every time I go to do a tear, I can't find my screwdrivers, can't find this, can't find that, and oh man. But I never actually go, right, I'm going to spend a couple of hours cleaning up. No.
See, I feel like that's. I don't know. I never got into that habit either of just like some people are very meticulous. They want to clear their bench at the end of the day or something. Yep. I don't know if that's like just a personality trait kind of thing, or I don't know. I don't trust people with clean benches, though. I'll tell you that.
Right.
The dirtier, the better.
Jim Williams style. All right.
Exactly. Yeah. I don't know. It's just. I think it's just maybe it's a mentoring thing or something, but. Something has to get it so that you get into that habit, but I never got it.
Well, usually we're in a rush, we just want to, quick, let's do this. Oh, there's something else on the bench. I'll push it aside. And then you do that 10 times and 10 things have been pushed backwards, and before you know it, I've got, 6 meters of bench space long here. Yet I work in 1 square foot, as you Yanks would say. Right. Because everything else, I need some room to solder the board.
We don't touch it either, right? Yeah.
No, that's right. So you just gently
you don't disturb
sort of
the artwork that is your junk pile.
That's it.
Yeah.
Oh, man. So if anyone is one of those meticulous, organisational, clean freaks, engineers,
they can send their pictures in.
Let us know. Send your picture in.
We happily take workbench of the week photos that are messy as much as I think last week's was messy and clean. Yep. I don't know. I have this kind of thing too. So whenever I start cleaning my bench, I usually have a trigger in my mind. Then I stop and I say, I'm avoiding something right now. I know that if I'm cleaning, I'm usually actually avoiding doing work.
Exactly.
So at that point, I've just trained myself to messiness means activity.
Yeah, yes, that's right.
I'm doing okay then.
You want to know what else she made me do?
Put up a air deodorizer. I don't know.
She made me throw out empty cardboard boxes.
Oh, jeez. Doesn't she know
I
that
know.
the trash room is for collecting stuff from, not donating to? We've all seen the videos.
That's right. I do need those 15 computer monitors, and I do need those 10 empty boxes. And
Turn it into an episode of Hoarders, right? It's where you're...
Right. Is there a reality TV show called Hoarders?
Oh, yeah, that's big in the States.
Right,
it's like
okay.
they go into people's houses, and I've never seen it. I think that's disgusting.
Right.
But, there's like newspapers stacked to the ceiling, and then they get all like...
Oh, yeah, no, I'm not that
There's like
bad.
psychological disorders there, too, but...
Yep.
There are different levels.
Right.
Well, I'm glad you dug yourself out, man. That's...
Well, I haven't fully done it yet.
Oh, yeah.
And I still haven't organised anything. So if you asked me, if you came in and said, "Hey, Dave, can I borrow a 2N, 2222 transistor?" It's like, oh, yeah, I've probably got one somewhere, but
just dig through the pile, man. That's what we all do. That's why markings are so important on parts, like we talked about last week, and how they're going away. It sucks,
And bags, and how do you categorize these things? Because I like to keep my components that I've got in a complete bag that I bought from DigiKey or whatever, Mouse or Farnell's or whatever, usually.
Yeah.
I buy them from scratch for each project. So I keep them all in the one bag for that particular project so that when I'm going back to work on that project, I know all the parts are in that one bag.
Right, yeah, you
But
don't
then
start
when I
pilfering
work on
from
another,
one.
Yeah,
Right.
well, that's right. But if I'm working on another project, then I've got to remember in my head that I've got, I've got one of those power MOSFETs. Yeah, I use that in that other project, so it must be in that project bag instead of having, a nice, properly laid out, power MOSFET drawers, with all my 10 different types of power MOSFETs.
Yeah.
So
I think the key in any kind of good workbench setup is to hold off on the junk drawer or the junk cup, as I have on my my mechanical workbench, for as long as possible.
A cup. Yep.
Yeah, because as soon as you have one, right? If you want to do it, if you want to have organization, that's good. Keep it going. But as soon as you have that junk bin or junk drawer, it's all over, man. It's just it becomes It's just the path of least resistance. It's just throw it right in there. Now I'm done. Everything's clean. It's like it's like Calvin and Hobbes when he shove all his belongings into the closet. That's how he cleaned. Right?
Yeah. That's right.
Yeah. I have been sorting through stuff as well because it is tax day here in the U.S. I guess not just Cleveland, but it is tax day in the States, and with more than 4 hours to go, right before the show, I finished filing my taxes. Just,
in true engineering fashion.
I love so much time, It's just, I'm fine, And, I did good this year. On the business front, I almost broke even. That's all I go for.
Yay. You'd be surprised the amount of money you spend on just toys and widgets
Stuff.
and how it adds up, little parts.
Yeah.
I'll buy a part, I'll buy $10 worth of parts for this little thing I'm working on, and you do that, 100 times, and it adds up.
Definitely. Well, and at the end of the year too, it's if you do, I don't know. So I learned about like LLCs and stuff like that. Like I have an LLC, and I learned about that stuff from one of my former mentors because he had one as well, and he's like, basically, at least in the States, I don't know, everywhere his taxes are different, but, at least in the States, it's like, if you have like $1,000 in profit at the end of the year, you have to pay taxes on that versus, I don't know, buying a CNC machine and, writing that off. It's like...
Yeah, hello. I think that's pretty universal in every country. Then come tax time.
Yeah.
If you've made a profit, yes, you pay tax on it. That's how the system works.
Right. Well, what I'm saying, though, is making that year-end purchase to... that lessens your taxable, profit. Basically, you don't have to pay taxes on it then, because you have
see that? That's a myth, right? You see that right at the end of tax time here, which is June 30th, right? If you go to the computer markets, right? On one of those dodgy computer markets on June 30th, or the last Saturday before tax time, it's packed. People are handing money, wads of money over because they think that they're, the computer's almost free because I'm going to write it off on tax. But no, folks, go and do the math. You don't save anything. Like, people think, oh, I'll buy the $2,000 computer instead of the $1,000 computer, and I can write it off on tax. If you actually do the math, you're not actually saving anything. You're still paying double. Like, give or take. It depends on your tax bracket.
No.
Basically,
I disagree with that. Well, at least in the States, it's different. But
right. Oh, right. No, here it's like, no, you pay... you basically, you're not saving that $1,000. You're basically still paying double.
Yeah.
So,
well, assuming you, so in the States at least, the estimate I always use is like any money that you make as a consultant or something like that. So say you make $100 as a consultant, at least in the States, between all the different types of taxes and everything, it's about 50% of taxes. Right. And because of like self-employment tax and everything else. And so if you have a year-end purchase like that, like a deductible year-end purchase, then I mean, like that's like effectively getting a 50% discount on it, because at the end of the year you're gonna have to either pay taxes on the $100 or spend that $100, and I don't know. Maybe I'm wrong about all this, and I'm sure that there's some consultants and everybody, the business people.
Well, that's similar how it is here, because if you're earning an absolute buttload and you're in the highest tax bracket, which might be 40-something% here, then it's if you still do the math, it's because it comes off your entire, because that if you buy the thing for a widget for $1,000, it comes off your entire taxable income. Like, it's not like you get that $1,000 back. It just reduces your taxable income by $1,000. And if you earn $100,000, it goes down to $99,000. And then if you do the math, then the tax, you haven't saved much. So it's the same here.
Yeah, I see what you're saying. Okay.
Don't be deluded, folks. Yep.
Yeah, and at the end of the day, it's still making, it's still spending money. So it's like,
yeah, no,
if
exactly.
If you don't need to buy it, then don't buy it.
That's it.
Yeah. So, that's all over. Thank goodness.
Right.
It's always a stressful time. It shouldn't be,
and
but it is.
And you owed some money.
Yeah, a little bit.
You poor bastard.
Yeah. Well, it's okay.
Yeah.
It's not like it was just a miscalculation on my part, not a big problem. Not like I'm not like rah 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 rah,
Right. All right.
Yeah. So, what's new around here? We have T-shirts designs on the way. I don't.
We do,
know if people,
and they're very cool.
Yeah, they should be released in the next week or so. We're getting some final touches from our graphic artists. We have graphic artists, and they're cool looking.
Graphic artists, yes.
Yeah. So we'll be releasing those in a week or two, and then sending out those T-shirts from the survey contest. Survey, I guess, participation drawing. So thank you again to everyone who did that. That was very nice. I'm still reading through a lot of that stuff because there's so much stuff to read.
There's a ton of stuff there.
Yeah.
Gold prices are tumbling.
They are. Speaking of financials, which usually wouldn't be relevant here, right? It's like, oh, okay, who gives a crap?
Who cares, right?
Well, no, it does affect us though, because I've complained about this before. Connectors get damn expensive. They're, like, all these connector manufacturers are like, oh, well, we were going to sell you this for $1, but gold's so expensive, it's $1.20 now because we put 10 micro inches of gold per
instead of 2 microns.
Yeah.
Because you can pay a lot. You pay the price of your connector. You can get different grades. A lot of people don't know this. You can buy different grades of gold coating. 5 microns, 10 microns, 20 microns thick, and
it's actually not microns though. So microns are micrometers. They usually do it in micro inches. At least in the States.
What?
So it's micro inches. Look it up, man. It's stupid, but it's true. 30 micro inches is the highest you can get, but that 30 micro inches of gold, which is what would that be?
It's micro something.
0.03 or 0.3 mil? I don't know. 0.3 mil.
And you can get the same thing on boards as well. When you get your boards gold plated, you can get cheap ass one hung low Chinese plating, or you can get really ultra quality thick,
Yeah. And it affects stuff too. I mean,
from Fort Knox.
I never realized that. I mean, until I really got into it and started seeing failure reports on when you don't have that kind of thing. But it can really start to mess things up. I mean,
make a huge difference.
Insertions and everything like that.
I just got a quote for a bulk lot of connectors, right? They're actually those gold binding posts, right? They're gold plated.
Yeah.
What I didn't pay extra for is the gold plate in, right? But they've got two different types. They've got copper ones, like a solid copper. You can get your connectors made, and they're much more expensive than your nickel, whatever alloy
tin
kind of.
No, it's,
your nickel plated steel or whatever they are.
Whatever it is.
Yeah. And you pay, like 30% more for the solid copper. Would you like the solid copper one, sir?
What is the benefit of having solid copper? I mean, it's just
I
the
don't
connectivity.
actually know. I would have thought it'd be softer or something, perhaps.
Yeah.
I don't know the benefit of a binding post with copper. If anyone knows, because they're both the same gold plating, right? It's just the metal underneath. So I'm not sure. Maybe it's less thermoelectric.
Less thermal resistivity kind of thing. I mean, how it actually conducts heat or what?
No, God, I'm having a brain fart today, folks. I do know.
It wasn't even tax day there.
No, as in similar metal junctions, right?
Oh, like the Seebeck effect.
Thank you. Yes. Yes, but we're
yes, like
talking about
thermocouples.
binding
That's what.
that's right.
Yeah, people probably
that's what
associate
I'm
the most.
Yeah,
right.
duh. And but these are
The
binding.
whole video
these are
you did on it.
speaker binding. The whole video I did, the whole tutorial I did on that. Yeah. You think I'd be able to remember it? My brain is just Swiss cheese, folks. But we're talking speaker binding posts here. Right? So if anyone knows the advantage of solid copper speaker binding posts, maybe it's heavier current. Actually,
maybe.
It could be because we are talking, really like 50 amp kind of, binding posts. So possibly that's the reason, actually, low. So it could be just the copper is better conductivity than the other.
Well, that affects it, though, too, because, I mean, copper's super expensive right now, too. I mean, to the point where...
Oh, copper's very expensive, yeah. People are stealing it from houses.
Exactly, yeah. I mean, bigger problem in Cleveland probably than Sydney, but...
Right.
It's just so thoroughly ingrained in every part of electronics, right? I mean, I know that a lot of companies moved from, I forget what it used to be. I guess it used to be tungsten that was the metallization layer on microchips. And now a lot of them moved to a copper layer because that's a lot more contaminating, I guess. That it's a crappier process to work with, but it also has better connectivity properties and everything else like that. So
yep.
Well,
they use that on the high end CPUs and stuff, don't they?
You talking about like heat sinking or the actual?
No, as in like part of the fabrication. Yeah, the metallization.
Yeah, right. But
process.
It's becoming more common in the lower end stuff as well.
Right.
So
okay.
And I think they still. I guess they use gold for the bonding wires, right? Those when you actually see connecting over from the packaging to the chip, but. I don't know, all that stuff, though.
I've always wondered, are they solid?
What, the
because
wires?
The bond wires.
I think so, but they're tiny.
Yeah, I know. Well, that's the thing. That's the reason that they could be solid gold, right? Is because they probably are, how many microns thick.
Microns, yes. I think that actually would be microns because that's kind of
right.
Yeah.
Yep.
Didn't we have someone on the show talking about
probably
the welding
Come on,
process?
How many shows have we done? I forget.
141 we're on right now.
Yeah, exactly. We've had so many people on.
Yeah.
Well,
you think you got it bad? I forgot to schedule a guest. If people didn't notice, we do not have a guest this week.
Guest,
yeah. Sorry. We'll try again next week. It's busy right now. It's tough, like you get busy at work and
you get busy totally. I didn't have enough time to look at the list today, so I'm completely winging this.
Yeah.
I mean, the difference from other weeks is
no difference really. No.
Well, usually I jump in 10-15 minutes beforehand and at least have a look at the links,
Yeah. Yeah, so it's interesting from from the actual all these material science side of things, right? They're still trying to improve it because everything's getting pushed lower and lower margin all the time, right? And so I've heard them talking about trying to go to I think it was like nanotube type of bond wires and stuff like that. And obviously the packaging is all shrinking, so you can start to do direct bonding and all the other crap. But it's a crazy science.
That's insane. How do you even get the little robot claw in there to hold the bond wire and then, weld it down into place? I mean, it's just stupid.
It is.
How do they do that?
I do not know. I've seen videos of it, but...
You used to work in a fab?
Yeah, but not there. I mean, I used to work in a fab, but the packaging was overseas. That's the crazy thing.
Oh, right.
You'd get to the end, and they'd be like, yep, all right, well, this wafer checks out, and we're sending it off to get...
And they just pack the wafers in cardboard boxes, and off they go, right?
Yeah, going to get cut up and packaged
hand it to that guy in the brown shirt, and...
Yeah. Well, and that's, I mean, a lot of the packaging is I think it's almost all in China and Malaysia, I think. Maybe.
Right. Okay.
Maybe a couple other places. But yeah, it's very concentrated on the packaging, and it's separate from the chip fab.
Why is that?
Because of labor costs.
Is that because it's a real shitty... Yeah, it's low cost because it's probably a real shitty process from a chemical point of view, right? And in China, they just... dispose of those chemicals,
I don't know about that.
OH&S, what's that?
Yeah.
I don't know. I could be. I'm talking out my ass there. I'm probably being, but
being Dave.
Yeah. But no, there's probably there's elements of truth in that. They take OH&S and stuff like that less seriously over their waste, less seriously than we do in the West. Sometimes.
Yeah,
so,
but I think normally it's not. I think it's almost always cost driven. I mean, there are environmental regulations and all of that other stuff, but
that costs money, which drives up the cost in the West.
Yeah, but not as much as labor. Labor is killer.
Right.
Well, if you look at the overall cost of like a PCB or a chip or anything. Well, maybe not in a chip, but anything that is hands on. Labor costs are just really, really important. So as we move to robots, right, it'll be.
No, you can do it anywhere, right? That's the thing. That's the
Right, and then the safety side of that becomes easier too, right? It's just it's not like, oh, are you being ergonomic and are you disposing of chemicals properly? I mean, that you still need to worry about the chemicals probably, but the ergonomic and the safety side of things with robots is, did you build a cage around it? Does it turn off when you open the cage? Like it's
tick end of story.
Yeah, exactly. It's not easy. It's not like it's easy by any stretch, but it's less human resource intensive, right? It's just
right.
And you don't have to deal with other stuff like this is actually a link from last week, but so Foxconn obviously is a big manufacturer of PCBs and consumer electronic stuff. That's the...
You think?
Yeah. Biggest private employer in China. And 400,000 people working on Apple products alone, I think it was. But we've talked before about them having problems with suicides on campus, actually. So they were the ones who put up the nets, to catch people and everything like that.
I'm sorry, I laugh every time I hear that.
I know
because it's a serious problem.
It's a very serious problem, right? But
it's the wrong solution.
It's a comically ingenious solution,
stupid
right?
solution.
Yeah,
cracks me up every time.
So they've taken it a step further though, and yeah.
How can they take it a step further? Well, do they put everyone in big sumo suits so they can't hurt themselves?
Yeah, they put them in hamster balls, right? They just bounce.
Right.
No, they fire you. That is the answer. So instead of, so basically they do some testing of people, and then they say if they're a risk for suicide, they fire them. And then it's like kind of like like in
how do they do that?
Office Space, right?
They give you a psych test, right? Office Space, yeah.
Yeah, it's like we fixed the glitch.
Right.
Yeah. But I mean, I think a lot of times
see how they could afford to do that. Like psychologically screen every worker.
No, I think it was more of a reports of this person is depressed.
Right, this person's agitated, so they bring him in. Right. Yeah.
Right.
Okay. And then make you even more depressed because they've brought you in and they're giving you psych tests.
Yeah.
So, right.
It's not the best workplace thing, but I mean, honestly, and this is another. This alone as an isolated incident is a sad situation, right? But in terms of like human resources issues and everything else, it's like, man, when there's robots, it's like that's just another checkbox in the reasons to do it, you know? Aside from the fact that they don't ask for coffee breaks and they don't do other things, it's gonna be crazy when robots really kick in. Once they really get that going for like PCB assembly and stuff like that, I don't know, man.
Yeah, but you think they would have done it by now if it was worthwhile? Because like something like PCB, right? Manufacturing a PCB, very labor intensive, right? Very labor intensive.
Cabling
Hopefully, I'm going to
harnesses,
get
right?
a video out on this. And yeah, it's like you think somebody would have gone, well, look, I'm going to invest money in an automated PCB manufacturing plant. But as far as I'm aware, please, if anyone knows of any automated PCB plant, let us know.
Well, you're talking about the mechanical assembly of it, right? I mean, not necessarily the surface mount stuff.
Yeah,
is
the actual
very well
manufacturing
documented.
of it.
Yeah. Well, okay, but what I'm saying is that like pick and place machines alone are technically a robot.
Assembly, that's totally done and dusted, right?
So
Except for the people who have to massage them because they're very finicky machines. They're still
right.
Just by the very nature of the complex tasks they're doing. Yep.
Yeah, so this would be the putting together wire harnesses, actually like soldering, like maybe large surface mount components that can't go through a wave machine or through a reflow machine, that kind of stuff.
Well, they
right?
do have selective wave soldering robots, which can selectively.
Yeah, that's true. Yeah, you can do like masking off and everything.
Yep.
But I mean, there are certain components that you can't do, like they can't go through water wash, or they can't. There's different steps of the process where sometimes it's just you need human labor to do that kind of thing. For now, and I mean, like wiring harnesses are getting. I know that those are getting more advanced as well from a mechanical perspective, but I think it always just comes down to cost balancing, really. I mean, if you can find someone to do it cheaply, then they just go with that. Why would you invest when you can just pay people standard rates and get away with it?
No, there has to be a financial incentive to do it.
Right.
And there was, in terms of the pick and place machines, there was a find that they realised, well, look, we can sort of automate this. Let's give it a go, and it worked. And they've refined that. Now hardly anyone places components anymore. In fact, us designers design boards to optimise the amount of machine placeable componentry.
Yeah,
because it just makes sense.
Yeah,
right?
if you
Because
get to
you're
20
paying for your
reels
machine
instead of
assembly.
21 on your, and you don't have to do a change, then you win.
Yeah, exactly.
You win the overhead.
You know what I want to see? Which
What's
is
that?
better than your stupid chip printing machine?
Well, go ahead.
A PCB manufacturing machine. You send your file in, out the other end it comes your double-sided, plated through, silk screen solder mask board. Out the other end.
Kind of like a... so that would be more of like a laying down like a silver nitride kind of... is it silver nitride?
I don't care how they do
whatever the conductive ink type of thing is, right?
Yeah, I don't care how they do it, but I want sure you got to feed materials in one end, so maybe you got to. Yeah, you could say, oh, maybe it's kind of sort of there with the LPKF machines, that etch out that, do the boards and stuff like that.
Yeah, those are subtractive though. You're talking about additive,
and
right?
I'm talking about additive. Well, once again, I don't care how they do it. Right, I just put raw materials in one.
Well,
end,
you care about solder mask though. That's the main thing that you. That's always the ultimate thing is solder mask. If you can get solder mask.
Well, solder mask and plated through holes. I mean, plated through holes. Oh yeah,
that's the other one, right?
Essential, of course.
Yeah.
But yeah, that's what I want. Push a button and out comes. It's got to be. Yeah, the holy grail here would be the solder mask and the plated through holes. Mm-hmm. I don't even care about silkscreen, but generally, if you can, silkscreen's not that hard. You can put it through a silkscreen print, right? Like a dot matrix silkscreen printer, right? Yeah, right. So that's probably the easiest part of the whole thing is silkscreen in the board. So,
yeah, that's tough with the. It's always the through holes. That's always tough. But if you're doing like rivets, I mean, and they have some of that stuff now where you can, you can insert, do a drill and then do a rivet insert and then try and
all
etch
that
around
sort of
that or
stuff,
something. But
yeah,
it's still pretty.
But I want it to be completely hands off.
Yeah.
A la the Chris Gamble fantasy machine.
Is that what we're calling it now, huh?
Yeah.
Come with me and you'll see a chip that's completely printed.
I will pay that.
Yeah. Get me my hat and cane, and I'll start. I'll hire some Oompa Loompas.
Some Oompa Loompas. That's it.
Oh man.
Oh boy.
Well, we had some.
Yes.
Speaking of Oompa Loompas, there were some notes from this week about.
How can you go speaking of Oompa Loompas?
Speaking of Oompa Loompas,
how is that a segue? How is this a segue? Amaze us with your Oompa Loompa segue.
I have nothing. I was just going to talk about chip printing. We have a bunch of stuff that's chip printing-esque. I don't know. There was stuff, and you and I both said the same thing, where it's like, oh, everyone's like, oh, yeah, this is the next thing. No, sorry, folks, this is not it. But there were some interesting news items this week for some theoretical, like what do they call them? Like
always
flakes.
Are. It's a big, heavily researched field, chip printing. Printing, circuits on flexible materials and blah blah.
Yeah, that kind of thing. Yeah.
There's always something new coming out every week.
Called.
It's nothing new, so folks. So stop sending in the links.
No, I'll keep sending in the links. I like it.
Oh,
it works
gives
Dave
Chris
up
a little.
and, it gives me a little boost. You get to start singing and dancing again, like usual. But yeah, this is out of Xerox PARC, which is good. That's another good thing. Just to see that. I'm glad PARC's still doing stuff. I mean, I thought they had slowed down.
That's surprising.
So that's, hey, power to them. I like seeing that stuff come out. But yeah, they say write print in the it's in the New York Times too. So I think the wide dissemination of this article and the fact that they say that it could lead to printing, quote unquote, the circuitry for a wide array of electronic devices.
Yep.
Yeah. Well, I mean, we'll see. Yeah.
Yeah. Speaking of printing,
yes,
and the lack of printing, UBM.
That's not a bad segue.
Thank you very much. I'm a professional.
Yeah, that's right. He does parties, folks.
Right. UBM, the huge conglomerate who own practically every online electronics magazine or something.
Remaining industry rags, basically. It's like one or two total companies left.
Pretty much. Yeah, they're all under this UBM banner. They've got an announcement. They've laid off some people and a whole bunch of people, and here it is. UBM Tech announces strategic shift towards community-focused media and events.
To synergize core competencies with maximal profitability.
They put that in there, but it wouldn't surprise me.
That was ad-libbed. That was ad-libbed.
Well, here's the tagline under that. Leads evolution of business-to-business media via integration of event and online communities. Oh,
Yeah, it's dripping
I am doing the
with
wanking
BS,
gesture here, jokes, folks.
Yeah, it's
sorry for the mental image, but yeah.
That's okay. Yeah, it's industry speak. It's fine. It's weird to think, that at some point there's people sitting in conference rooms analyzing how to better influence you and I and all of our listeners. It's like, it's weird to think about. It's almost like, it's not, I wouldn't say stalkerish, but it's a little creepy. It's like, how about you just give us app notes and fun articles? Is that a lot? Yeah. But yeah, so it's sad. They lay some people off, and the thing that I'm kind of angry about, not angry, disappointed. They got rid of Design East, so the Design West is going on, I think, this coming week. But
are you going to that?
No, I'm not going. It's next week, I think. Maybe it's next week. I don't know when it is. But yeah, so they canceled the Boston one, which I was actually thinking about going to.
Oh, did they? Oh, okay,
yeah,
right.
Yeah, so that used to be ESC Boston, but
that's right. So ESC is dead, Boston. ESC Boston, but they're still going to continue with ESC Silicon Valley.
I think that's the only one, because there was Chicago too. I started by going to Chicago, so yeah, it's they're scaling back, and I don't know. I'm sure that there's reasoning for it, but it's just too bad because it's usually a good way to get to know people on the East Coast. If meet up with people there, and good excuse to go to Boston.
I love one of the examples they give here.
Yeah,
they're an illustration of the success of one of our things is the 2013 Game Developers Conference, world's largest and longest running event serving game development. Blah 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 blah. A community of over 1 million unique visitors each month. Woohoo! My forum gets more than that. Whoop-de-doo. I'm sorry. I
don't know. It's a game site.
Sorry, I just found that figure. They're boasting about this figure as a huge success, and shit, my little forum's got more than that. Sorry, UBM, whoop-de.
Yeah. Well, the interesting thing is that I didn't realize though that they killed Test and Measurement World too. But
yes, that's the other big news, which makes it relevant here, folks. Yeah, so TMM
that's
World
too bad,
is gone.
I'm sure there'll be other ways to get that stuff. But
and I don't know if we've ever mentioned it on air, but they tried to recruit both of us for Test and Measurement World at various times in the past.
Yeah.
Yep, and we rightfully turned them
declined.
down.
We declined.
We declined.
Yeah. But
politely declined. Yep.
It's too bad that that's shutting down too. But the thing I didn't realize though is that EE Times hasn't been printing paper since January. Apparently, I didn't realize that December. Maybe if you go back and listen to, we've talked about it, but I don't remember ever hearing that or anything. So it's interesting because you think about old analog engineers, and the typical
graybeard.
Graybeard, right? Just like they want paper, and I enjoyed paper once in a while.
They want paper and messy benches.
That's right, exactly. We know what they want. No, we don't. But a lot of people do still haven't. It's the same kind of thing with catalogs, right? I mean, leafing through can be much more rewarding than going online and clicking articles and all that crap. So it's too bad. I mean, it's just a changes kind of thing, right? Cue David Bowie.
Yes. So what are they bloody well going to focus on?
Yeah, online.
And do they actually tell you in this article? Does it
Yeah, online. I mean, that's online.
Right, online. And so they're basically going to kill every single print.
I don't know. I don't know about
they've
that.
got. Is that the? Well, surely that's the ultimate game, right? A goal.
Probably. I think who was it? Chris Anderson was talking about that on here. Maybe he was saying, or maybe it was on a different thing. But at some point, I remember hearing Chris talk about having boutique printing and having basically high end. The equivalent of having people listening to records these days, right?
Exactly. You print a full color, gorgeous, glorious book, and they want to own it because it's a thing worth owning.
It's the aesthetics of it. Yeah, exactly.
Yeah.
And I could see that same kind of thing happening here. That if there were people that were interested in it, they pay a surcharge or something like that, and companies pay for it.
Yeah,
whatever,
and they get the printed copy, and then you print on demand. You only have to print.
Right.
I don't know why they wouldn't do a print on demand model.
Well, technically they're doing that now, I guess, or they were doing that for.
Well, I guess
demand is.
I don't know why you wouldn't take people's money. If they want a print edition, give them a damn well print edition.
Yeah,
and take their money.
Yeah, if it makes sense financially, that's usually that's what it comes down to, right?
Well, maybe they've done that. Maybe they're sitting around. Look, we've only got 1,000 people who are paying for the print edition. It's not worth our while even bothering.
Yeah. Well, and I mean, there's other magazines. So you were mentioning there's still a bunch of tech magazines in
Australia,
right?
electronics, not including Silicon Chip. There's Electronics News I've got right in front of me here, and the other one's What's New in Electronics, 2 industry mags, and they're still printed. I get them.
Are they ad supported, or do you pay for those?
No, they're completely ad supported. They're free. They're industry mags.
Okay.
So they still follow that traditional model of the free industry magazine because it's because it costs a lot of money to advertise in these things, right?
Yeah, it does.
It costs an absolute buttload. I've posted a link to how much it cost to advertise in UBM, for example, in their both online and print media, and it's a metric buttload of money, folks. I linked it in the blog article I did about how not to sell out to, in terms of bloggers not selling out. And very expensive. No, but see, even in a pissant country like Australia here, with hardly any electronics industry, right? We've still got 2 printed magazines.
Yeah,
3
well, sometimes
if you include
it's scale
Silicon
too.
Chip.
I mean, you think about the amount of money it takes to run a big company versus a smaller one. Sometimes you can kind of skirt by
true.
if you're a smaller tech rag that might be able to have a small
well,
staff.
Silicon Chip is an example of the small rag, right? It's still privately owned. There's only like
Yeah.
less than half a dozen people working there, whereas the other two are like owned by bigger conglomerates.
Oh, okay. So then they're just like supported by other
there's
divisions
other
and stuff.
things, I guess. Yeah. Although ultimately, if it wasn't profitable for them, they wouldn't do it. I'm sure.
Right. A lot of
So they're obviously still getting enough old school advertisers to, keep the magazine alive. So what we want to know, folks, because Chris obviously doesn't know, even though he's a Yank, how many printed industry engineering magazines are left in the US or in your country? Don't want to leave out other countries, please. Other, other countries. How many electronics magazines do you have?
Yeah.
Trade ones we're talking about here, not hobby.
Yeah. Right. Well, and so there are other examples of like the higher end stuff. I mean, like you get like a subscription to like Make Magazine, right? It's like $15 for a quarter, I think.
Right.
Something like I think it's like $60 a year, and that's a nice magazine, but it's definitely not cheap, and it's definitely not free. It's not ad supported, so
no, that's right.
Right. And they are doing a workshop. Did you see the news from that?
There is news on that.
Yeah, they did this last year. The first one was last year, where they have a lot of familiar names. I think like Chris Anderson and I think Zach Hoken from Hexcelerator will be there too. Lane from OSH Park will be talking there. So there's a whole list of people that'll be talking there. And it is a really, really nice list. But it's like kind of like
a good event.
Yeah, a new industry conference, effectively. Same kind of price tag as you'd actually expect from like an industry conference, which I was surprised at last year. But the interesting thing from this year is that they're issuing a call for prototypes, which I didn't see coming. So basically, though, they're like, yeah, you can get up for five minutes, and if you haven't taken any VC funding or you haven't done any Kickstarter or anything like that, then you can get up and give a pitch in front of all these people, many of whom are well connected, and some are, I guess, going to be investors, right? And so maybe it's a thing.
That's pretty cool.
Yeah. So, and it's interesting because it is targeted at like the open source hardware and and just hardware in general, right? That alone is a good start. So, if people are interested, they should look into it. There's a deadline is the end of this week, Friday. So we made it before the deadline. We announced it before the deadline. That's usually pretty good for us.
So, and going back to the industry, the UBM thing, considering that they cancelled ESC Boston, are we looking at the end, possibly the end of industry events like that?
Maybe
I don't
consolidation.
Want to spell doom and gloom.
No, I don't think.
Consolidation, perhaps.
Yeah, I mean, if anything, it would just be like a couple smaller events. But I'm sure that they're still going to have one big event, and if they don't, that someone else will, or
there's somebody else will start it up. Yeah, that's what I'm.
Right.
Yeah.
Or it'll just ad hoc happen at like Maker Faire or other, like
exactly.
Chaos
That's what I was getting
Camp,
at.
that kind of stuff.
Yeah, that's right.
It's just as the landscape changes and there's different places to gather, or it'll fragment, right, and it'll go back to just being embedded stuff, right, like ESC used to be just embedded, but then it kind of expanded.
Yep.
Ebbs and flows, man. Ebbs and flows.
Yeah. well, the same thing happened here. We used to have an electronics industry event here every year, and then it died out. Due to, they tried to build it up to, include everything else, like big, huge industrial machinery and then it became like 5 in 1, so the electronics stuff just got eventually, and they eventually just discarded the electronics thing. And then a couple of years later, it sort of came back. They decided, right, we want, or another new company came and decided we want just an electronics exhibition again. And it just started up again from nothing.
Yeah. Well, that's kind of the same thing happened with like the CES, right? CES got really, really big, and then this year, South by Southwest, which we talked about a couple weeks ago, that got really big, right? And so it's like, it just it all flows around, and everybody's looking for the hot new thing to go to or whatever, and variety. I mean, that's the thing too, is variety. Variety does help. So if this shakes things up, it's fine with me. I just want to go to Boston.
But you've got to be careful. The variety can also dilute it.
I suppose. I don't go to many conferences, to be honest. I mean, like,
No,
look at when I've been an active engineer, Dave, right? I mean, like, I effectively started doing electronics not in a fab in 2008 again. So I don't know if you were paying attention since 2008, but not a whole lot of money floating around these days.
No.
I talk to people about that. They're like, yeah,
right.
I used to go to trade shows, and I'd be like 3 or 4 a year.
Yeah, the company had sent me on all these junkets.
Exactly.
And now it's
yeah. Like out boozing on the company card and stuff like that. And it's like, no.
Now they won't even give you a day off to go to the on your own dime.
That's how I've almost always done it. I've always done it on my own dime. I've usually taken time off because I do it for networking, right? That's how I got to know a lot of people.
Yeah, that's right.
That's.
Yep.
So yeah, and I do suggest that. I mean, it is worth it from a professional development standpoint. Hopefully, you can get in for free by being a blogger or some other kind of shiesty way like I did. But if you can swing it, yeah. I mean, even if you just go to walk around the floor and meet people, that's what that's all about, is meeting people.
Yep. That's if you are one of those social engineers. If you're one of those,
even if you're not,
social retards, though.
Yeah, come on. You're not. We know you're not because you've taken video of yourself at this.
Yeah, but no, trust me, I'm not a very social person.
Well, I'm not either. I mean, like, it's easy for me.
Especially
on
way
microphone.
back in the day. I mean, shit, I wouldn't talk to anyone.
You've become a
away,
social butterfly
humans,
since then. Yeah. Yeah.
No, but look, right? No, just the fact is, right? How long have I had this? I've had this lab for a year and a half or something, right?
Yeah.
Yeah, right? Let's call it a year and a half. Guess how many visitors I've had to my lab?
3.
Yeah, about that.
Yeah, okay.
Right?
I noticed I haven't gotten an invite yet. I don't know, Dave. It's just,
right.
I'm waiting. I'm sure it's in the mail. It's probably just slow U.S. mail or something, getting over the
But I thought you were scared of our spiders.
Oh, I am. Oh, my God.
Pussy.
Yeah. So what else should we talk about?
On the list?
Yeah.
We pissed away the show already.
Have we? Oh, we should. Oh, we need to talk about our sponsor then. Have we?
We
definitely
were supposed to do that halfway through.
Yeah,
we kind of implied
we got it wrong last week.
Well, I'm trying to get us off the hook here. Come on.
No, we were wrong.
Well, we assumed that this VIA ASIC stuff was reprogrammable.
Right.
Reprogrammable. And, of course, the name alone should have
via what?
given us a clue.
Via FPGA?
Hello, McFly.
Yeah.
Yeah, ASIC, in the name.
Yeah.
Usually implies non-reprogrammability.
Yeah.
So, sorry about that. It is a mask process,
Right, yeah, so it's the same kind of
mask process. It's going to be a cheap mask process.
Right.
But
yeah,
still,
so
it's
We talked about that last week, or earlier in the show, rather, about like the masking process and doing the metallization layer. It's basically that. So if you look at all the different like VIA 1 through or VCA, is it VIA configurable array, VCA 1 through VCA 12, and then there's a couple others for like the ARM based one and everything. All of those are basically like that's proven silicon, right? And then you basically do.
Join the dots.
Yeah, you join the dots in the VIA Designer software, which is what is actually sponsoring the show, that's actually what ends up telling the fab what to crank out at the end.
To actually make. That's right.
But yeah, the benefit of that being that it's already tested, so the actual underlying stuff's tested. You're just kind of hooking it all together. So effectively, it's kind of like moving a PCB down into the metallization layer. And that's probably an easier way to think about it.
Yeah.
Hopefully, I'm not saying that wrong.
You're just getting the individual. You're buying the individual chips from DigiKey. They're all thoroughly tested. You got the data on them.
Yeah.
And then you just you manufacture your PCB, and sometimes you might have to respin it because you goofed your PCB, and
right. But that's your fault.
Yeah, it's a very exactly
because the chip already
works.
It's
your own dumbass fault for not for not thoroughly checking.
Yeah, and it's interesting because it's actually the cost stuff. I mean, so they also do all the talking to fabs, and they work with a bunch of different fabs for that kind of thing. So it ends up bringing the cost down, and that's another advantage of them. So people should check it out. Go to viadesigner.com/theamphour. And then one thing that we heard about after we published last week was that you get a free year membership. It starts as a month trial, but it actually will go a whole year. There's a code. I think it's AMP100, but we'll have that in the comments or in the show notes from this week. So,
and you get the software free for a year. It's normally like 500 smackers, isn't it?
Yeah, exactly. So
nice.
Benefits of being an Amp Hour listener is not
Give
just a chance to wear T-shirts anymore. It's also free software.
And that might be a good thing to put on your resume too, if you've used a tool like that. Even if you just played around with it and you've, I've played with, some ASIC design software. Hey.
Yeah, true. Yeah. I mean, this is still like system level type of design, right? I mean, it's knowing how you need to hook together different. There's transistors on board, caps, and everything else, right? And then larger
and you've got to do
stuff like
simulations
ADCs
and everything else to,
Yeah, and it would be good software to use, especially as it grows in popularity. So, I think it's always good to have that kind of stuff on a resume.
For sure.
It's interesting as a comparison point. So I saw this on Planet Analog today. It's actually a chip consultant was writing this article. So this is like the other option, which is much more research intensive, but it's also interesting. And I think we've mentioned it before, but there's actually an open source layout program. So if you wanted to not just do the layout, have a proven chip, but then actually try and dive down into the transistors and everything. This allows you to do that. Now, that would scare the crap out of me.
$3,000.
Yeah.
Oh, yeah. No, exactly. It's a lot of work. This is a lot of work compared to something like VIA ASIC, right? This is like, you're designing your own chip transistor by transistor, folks. There's a lot that can go wrong there. And and it's very intensive to learn that sort of thing. A tool like that, as opposed to a higher system level one. But if you need to, for some reason, because you really absolutely need, a transistor level custom silicon, then you can do it for about $3,000.
Yeah, which is cool. And I mean, like, that stuff is it's an interesting thing of just like, I took some chip design classes in school, but I didn't know what the hell I was doing, right? I mean, but the fact that there is that software out there too, it's pretty cool to be able to look at all that stuff. It's
absolutely,
it's crazy. It just always seems like it's way out of my reach. That it's just impossible. But people are out there making that stuff. And in terms of analog, if you get decent at it, you can make a lot of money.
Oh yeah,
yeah.
But to get decent at it, you have to actually spend that money and spin the silicon.
Yes, yeah,
so,
you can't just simulation.
But once
is
again,
not
this is something you could put on your resume. Yeah, I've played around with and used these design tools, these ASIC design tools.
Mm-hmm.
You don't have to have actually made the silicon.
Yeah, and I mean it's not going to be perfect either, right? Because if you try to go to TI and be like, well, I learned on Electric, right, this open source chip design program, they're like,
yep.
Well, we use Cadence, so see you later.
Yeah,
or
so
whatever
tough
they,
kids,
Cadence or what's the other one?
Oh, I don't know. Mentor, they do one.
Yeah,
you're right.
That's it. Yeah, so those are the two, and it's like, usually the tool, knowing the tool is just as important sometimes because of like knowing the design flow and everything else. But it's interesting. I don't know. I thought it was
the
cool.
catch, folks, is that it takes 4 months to spin your chip.
That too. Yeah.
So you submit it, and you get your chips 4 months later.
Right.
So it's not exactly a fast turnaround.
Right, and we should clarify, this is for if you're designing your own thing from scratch. Maybe I shouldn't have brought this up after the VIA designer sponsorship notice, but this is if you're spinning your own chip from scratch, then that's the 4 months.
This is... Yeah. And then, but before that, it'd probably take you 4 months to design your bloody chip. Whereas with something like VIA ASIC, it'd take you, a day, because you build at your higher level abstraction,
Well, it's the same kind of thing
using pre-existing blocks.
If you had PCBs back in the day, right? I mean, I'm sure that you spent more time when you were designing PCBs back in the day, right, with all the tape out and everything, making sure that's right, because it was so much more expensive, so much more time intensive that you really, really wanted to get it right. Versus these days, it's like, okay, it's done, get it out the door.
Yeah,
hope it's
get
right,
out the door. Oh, I can respin in a couple of days if it's wrong. Who cares?
Exactly.
Right?
Yeah. And that's the benefit, right? That's the benefit of moving to faster prototyping type systems and just having more commodity type hardware like PCBs are at right now. So, and once chip printers, yeah.
That is interesting. Actually, I don't know whether that's just old age or whether I'm looking back with fonder memories and what they were. But I can't recall an incident where I actually goofed a hand-taped layout. Hand-taped PCB layout.
Yeah.
Because as you say, you put a lot more effort into it. You have a lot more invested in it.
Yeah.
I can't remember. I don't know.
I don't know.
But of course, I've goofed plenty of PCBs in my.
Me too.
Using modern tools, near enough finished. Tick, send it out to the fab, and you get it back. Oh, do.
Yeah.
I goofed something up.
Well, this is so a question I had from this week is actually something I've run into with, and maybe you don't ever run into this, but the thing that keeps hitting me over and over again is like, and I think this is still my youth showing and my inexperience showing, but like I have an idea, right? I'm working on something. I have an idea. I say, okay, idea ready to go. Let's go. And I work on it, and then like a month later, I run into a brick wall and I'm like, oh, this isn't going to work. Right? And then I back way up, and then I start and I say, let's go. I have idea number 2. Work on it, and then 2 months later I say, nope, that's not going to work either. Right? And basically my question is how do you teach that like early iteration and like the, like, I don't know. I think it's just like a natural thing for young engineers to just say, well, the first thing, of course it'll work, and just go.
Well, there's two different sides to this, I think. One is that, in your case, are you talking about your work projects or your personal projects?
Yeah, both, actually.
Right, because I find that with my personal projects, that is a lot more likely to happen.
Okay.
That I'm going to change my mind and change direction and go back to the start again.
Okay.
And,
Yeah, we've heard about that, right? Power supply project, yeah.
Power supply, all right, I've done 5 different variations of my power supply project at least, and 4 different ones of my microwatch and, all sorts of different things. I think
some of that is because you want to be working on certain parts of that too, right? The design is the fun part, the dreaming is the fun part.
It's the fun part, exactly. So I go, it'll be fun to start with this new idea, whereas at work you can't afford to do that. Well, you can less afford to do that because you've got a deadline and you've got to, and people are relying on you and, well, your job's on the line and, and, well, you just do it, Yeah, I mean, there's like something in your brain that switches into a different mode that allows you to, battle through and not go back to the start and try again.
Well, sometimes you're just told you're not allowed to go back to the start, too. That's another thing.
Yeah, exactly.
No, there's no more money. If you don't do this, then we're all, gone.
The entire 10 million project is riding on you.
Yeah. Yeah, I mean,
no pressure.
It's tough. I mean, I guess at a certain point, like, you just have to kind of eliminate some of the things won't work and then just kind of start running with the next thing that's available or the thing that's most likely to work. But I don't know. It just seems like a youth-induced situation still, like, of course this will work. Yeah. This will be fine, And then slam, you hit that wall, It's like you get smacked by the large stick of reality, I don't know. It's
because with the personal projects, you often get blinded because you're so excited by the idea that you might miss some practicality down the track.
Yeah.
Whereas with work ones, I'm going, this isn't my idea anyway. Who gives a shit? Okay, I'm only going to focus on, will this work? Because you don't want to look like a dick. Whereas your own personal projects, you don't care if you look like a dick.
Right. You're trying to maybe dream blue sky a little bit more, dreamscape it, right? It's
exactly. Yeah, but at work, because it's usually not your idea, you go, oh, right, I've got a job to do, and I don't want to look like a dick, and so therefore you're going to focus on all the little nitty-gritty details that need to be right.
It's a question of how much R and how much D you're doing, right? I mean, I guess that would be the ultimate thing. If you're doing a lot of research, then you do have to do a lot of iteration and kind of stepping through different ideas. But even in that case, right? So like I saw a article today about how they prototype Google Glass in like a day or something like that. Like just a basic concept. But even with that, it's like, how do you go from saying, okay, well, this works in this limited case, and then trying to expand it to, this will work in every case, right? I mean, like, I don't know. It just seems like
that's 20 different iterations. I mean, that's,
I guess so. Yeah. I guess you just need to throw a lot of stuff at the wall, right? I don't know.
Yeah, of course.
I was just thinking about it today and thinking, man, I still got a lot to learn. I mean, that's a very good thing, right? I like that it's not like easy yet, but on the other hand, it's not easy yet, Dave. Yeah. Stressful. But stress is how you learn, right? That's how you learn.
Yeah. Yes, I think so. And you learn by failing.
Yes.
That's what we've always said. Yes.
So we had questions from once I had said that we weren't going to have a guest this week, I asked for some questions, and on Facebook and by email and a couple other ways, people had sent in questions. So we should get to some of those.
Shoot.
I think we might have covered this before, but two different people asked about. Yeah,
we've always we always say that, and we always have covered. Just assume that we've covered everything on the show.
We've definitely covered this before. I can't believe you guys haven't listened to episode. But yeah, so like FPGAs are always a big stumbling block for people, and like how to get started with them and stuff like that. And so that was one of the questions of not just where to start, but also what to start with, and projects and how to actually dig into it. And
I've got the answer for that.
Oh, good.
The universal answer to starting with FPGAs, and it's very similar for micros and everything else, is start with a working example. Buy your demo board that has a working example, and then work backwards. Just get it going, and then figure out how FPGAs and everything and all the configuration fuses and everything else works later.
Yeah.
And if you want to copy their example circuit, right? And then figure it out how it works. Don't try and figure out how their example circuit works and then implement it in yours. Just copy theirs and then work backwards.
Yeah. Yeah, I think they're getting a little cheaper, but I had started on I had done some work with like some of the the embedded micros before, or the softcore micro stuff from Xilinx and Altera before.
Yep.
And that was fun because it was just like those are, like I said, those are a little more expensive, but especially if you have micro background, it's tough to make that switch. Yeah. So, but we've also mentioned before the Papilio, I think it is, or Papilo.
Yep. Oh, I've got one of those. Yeah.
Zess, Dave Vandenbout's company.
Yeah, there's many of them. There's Digilent and all sorts of ones out there.
Right.
And the thing is, they're so hideously complex that if you try and start from scratch, right? It's just not going to work. And when it doesn't work, you don't know what the hell is wrong, right? It could be a combination of 10 different things wrong, and you think you solved it. No, it still doesn't work, still doesn't work, still doesn't work. Oh, solve another problem, still doesn't work. Right?
Yeah.
Start with a working example, then work backwards.
Right.
That's the way. It's the only way to do it. Otherwise, you'll just get frustrated, and you'll go, these FPGAs are shit, and I'm never touching them again. Nothing works.
Yeah. From a contextual standpoint, I mean, like, actually knowing why to use them, that's a whole other thing. I mean, and there's a lot of stuff out there, but, I mean, DSP is a big one, so if you need to, like, do filtering, anytime you need to do, like, lots of iterations on something, so if you think about, like, math operations, that can be really good in an FPGA, because even, like, DSPs, like, the DSP's the chip, those are often just micros that are running really, really fast that have dedicated hardware to that kind of thing, versus an FPGA, you can actually start to level out the logic and run things in parallel, and that kind of thing. That was always my favorite side of it, was actually getting to do parallel processing and stuff. So
parallel is the key. If you're doing high-speed serial to parallel conversion or something like that, and you've got 10 channels or something like that, it is the best solution.
FPGAs are really, really good at state machines too. I mean, you can do state machines obviously in micros, but FPGAs are great at that kind of thing. So if
you're just running a soft core and that's it in your FPGA,
you're wasting
basically
money
wasting.
and power.
You're wasting your time, money, package, space, power, everything. Right?
Yeah.
You just no. Right? You've got to have something else, VHDLE in there, or Veriloggy in there.
Right. Or if you're planning on messing up a lot, that's another thing. But in those soft core flows, right, where you do have a processor in there, you don't want to like change it around a lot because then you have to recompile all your microcode for that. And
Yeah, that's right.
Mess. That is just a mess. So there's a lot of cool things you can do, but it's like Dave said, starting from a project can really help. So, good luck, guys. You can do it. You can probably, I'm sure EEV blog forum people would happily offer some projects. Yes, I have
a dedicated FPGA micro section there. You can ask.
There you go. Yeah. All right, we'll link that in too. Yeah.
More questions?
There was a question from Kenny about choosing op amps.
Oh, choosing op amps. Oh God, how long's a piece of string?
How long? What does that mean?
Well, like how can I choose? He's basically asking how can I choose? Have you got any suggestions for choosing op amps? And it's like, well, that's one of the how long is a piece of string question.
I don't still get that, but I'm guessing you just mean there's a lot of options.
This doesn't translate to American.
I don't think so. No, I don't think so.
How long is you don't know the phrase how long's a piece of string?
No, I don't think so.
Seriously?
I think we've reached an impasse, Dave. Join us next week as Dave and I fight about different Aussieisms.
Well, it's like I thought this was pretty much universal around the world. I didn't think it was an Australian expression.
Maybe
at all.
it is.
Sure
maybe I'm just.
You're not cultured enough. Yeah.
Yeah. I'm not cultured enough, says Dave. Yeah.
I'm the epitome of culture.
Right. Exactly.
Yeah.
Yes.
Well, the clue to it is in the nature of the statement itself. How long? If I ask you how long is a piece of string, you're going to go, huh?
Yeah.
Yeah, okay. A piece of string is however long you make it, right? Similar thing here. Like, it's...
right, there's so many inputs.
Give general
that
advice. There's so many answers that you don't, I mean... It's,
well, no,
it's hard to answer.
So here's the thing. So Kenny was asking about, he has an ultrasonic transducer, and then the frequency of operation is upwards of 40 kilohertz, right? And then he says audio op amps won't work, which is good, because that's, he recognized that to start with, right?
Because but why don't they work?
Because of the gain bandwidth product. That's what he's saying. Although some of them do have higher gain bandwidth products, because in op amps you need more gain bandwidth product if you're going to be doing feedback and everything else, right? So...
the gain bandwidth product, for those who don't know, the gain of the op amp changes depending upon the gain. The bandwidth changes depending upon the gain of the op amp you have. So if you're operating at times 1, yes, that 1 megahertz op amp is going to work to a megahertz.
Right.
But if you have a gain of 10, wah, or 100, wah,
it starts to roll off.
Bandwidth is going to bandwidth is going to drop proportionally.
Right. Yeah, and that's just from the internals of the op amp and everything else, the compensation cap in there, whatever that cap is called.
That's if you have a compensated op amp. There's another difference between op amps. You can have compensated and uncompensated op amps. General rule of thumb, compensated op amps, generally you want to try and use them because they've been optimized to be stable. Whereas if you get an uncompensated op amp, all bets are off. Good luck.
Do it yourself,
Do it yourself,
Right.
Make sure that thing's stable yourself,
Right.
So,
and I know this would be a very unpopular piece of advice if Bob Peace were sitting here still, but he's not. So LT Spice is always at your disposal, right? I mean, there's tons of Spice programs out there, and so that's a good way, especially because those kind of things have it built in. Now, it seems like he has cost in mind, so that's a good place to start too. I mean, you can always go to a distributor and sort by price, and then
go to DigiKey and sort by price. That's how you start.
Exactly. Yeah. Or in this case, since it is a defined application, right? I mean, he's talking about ultrasonic transducer. You can go out, you can find an app note for the same kind of thing, right? So you find, LM whatever it would be, not 324, but whatever the part might be, right? And then you type that in, you say similar parts, and you get a whole list of parts that are in the same spec range, and then you can start to optimize for price more. And if you start if you start with an app note and they give you a certain part and it's $20, and then you go and search for other ones and they're all $20, well, you need to look at your application more and see if you actually need the specs that you think you're asking for, right? I mean, or you're just priced into an expensive market and you just have to swallow it. Sometimes happens. If you need super super precise or super fast or, then you go to eBay.
And one thing I would say is that, are you driving a line at all?
Yeah.
Because
right.
once again, driving a capacitive load can be a killer for an op amp. There's another design criteria.
Right.
Are you
Right,
trying?
and so-
Is that are you using this amplifier at the transducer and then driving a line to something else? If you are, well, there's a whole different requirement.
Yeah.
So,
And
Look out.
this kind of advice I give of looking at an app note that I think me from 4 years ago or 5 years ago would have looked at me and put a ugly look on my face and be like, oh no, I want to design it, right? And it's like, well,
right. No,
you can.
no.
I mean, you could start from scratch, right? But it's kind of the same thing that Dave was talking about with an FPGA, right? Sometimes starting from a known quantity can help, and then you can start to optimize for what you really need in the case of cost or more performance and that kind of thing. I don't know. So actually, Matt Richardson did a video today about artists stealing. Basically that there are no original ideas. We've said that a lot on this show before, right?
Right.
But,
Yeah.
it's a tough mental switch to make because I think, especially like in school, it was always like, oh, well, I'm going to design stuff when I'm done with school. It's like, well, yeah, design stuff, but more remix stuff and redo stuff.
Yeah.
It's like there's only so many levels there.
That's the thing. Electronics is one of those fascinating industries where you can achieve a hell of a lot with not a huge amount of detailed knowledge, right? If you've got an idea in mind, you can find and take all these already working example app notes or whatever and piece together block by block, and you can get you can do some incredibly advanced stuff with not much detailed knowledge of how those op amps work or, all that sort of thing.
Yeah.
If you just carefully take these example circuits, I mean, you can get by a whole career not knowing how an op amp works inside, right? Sometimes, right?
Probably, yeah.
Yeah. I mean, that's not uncommon. You just never have to worry about it sometimes.
I don't know, but
Because,
not
right,
common,
if
but yeah.
in this case, right, well, no, right, but it does actually happen. You want an ultrasonic transducer, there's app notes out there that show ultrasonic transducers and which op amp they've used. Somebody smarter than you has already chosen it. Bang, it works.
Yeah, and I think that's a mental switch too. Like some people want to dig down into the details, right? But sometimes even if you do want to dig down into the details, your boss is breathing down your neck. You're like, no, you got to get it done. So there are different levels, right? I mean, it's always just about optimizing for what your situation is, and making that mental switch was tough, but it's just life. It's just it's like okay, well. If I really want to learn the details on something, I come home and I work on it, right? I just learn about that or I read about it, and that's how you get your design jollies, or you go work for a chip company, you write the damn app note yourself.
Right.
And talking to people that do that doesn't sound like fun a lot of times too, because it's
new.
Yeah. I'm doing this wrong. A month later, I'm doing this wrong. A month after that, oh, the silicon isn't working right. Oh, crap.
And if you want to know how long it takes to actually write stuff,
oh yeah,
I just put a post last night because somebody on the forum asked. Somebody had the idea that I could make money by writing app notes, right? I can make like little app, little design brief notes or something. And they said, if you release one of those a week and X thousand of people bought it, you can make X thousand, blah, 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 a year, right? And they made the offhanded comment, sorry, I forget who it is, that, it'd only take you 3 hours to write. And I just laughed, right? My reply was, it only takes 3 hours to write an app note, laughing emoticon, right? With a, and then to prove it, I wrote a blog post last night, a text blog post, and you can read it. It's just been uploaded of how I built built my new video machine or spec'd my new video machine. It took me 2 hours and 15 minutes to write that blog post.
Right.
I timed it with a stopwatch.
Yeah.
And that's just writing out text. Right?
Oh yeah,
it's a long blog post, but
that's
it's
without the research and everything else behind it, right?
The research, the diagrams, everything else. I mean,
you look
holy crap!
Right, so the golden
it could take you a
standard
month to write a good app note.
Yeah, exactly. Jim Williams spent multiple months on app notes, right? The best ones. There was 140-page app notes, like you don't write that
that's
in a couple
crazy.
hours.
That would have taken him 6 months. He would have worked on that for
Yeah.
It's crazy.
So, yeah, and it's a lot of like that with a lot of app notes. Like it's interesting that it still exists in the marketplace, that these chip companies are willing to do that kind of stuff. But it's because it's don't kid yourself. It's because it's a sales tool. It's because that's how they sell chips, is by offering these example circuits, right? I mean, that's why they do it.
That's right.
Hey,
and it works. We're whores for that kind of thing. Even I'm a whore. I don't want to reinvent the wheel. I don't want to spend time dicking around. I'm too busy getting my fantastic widget idea up and running. I don't care about how the op amp stays stable on that thing. No, I just want to use a bloody circuit that I know is going to work. Yeah.
The cult of done.
So I don't have to respin my freaking board. And, when my design comes back and not working, I don't want to have to breadboard that up and make sure my op amp's stable.
Right. It's fun at first. I mean, it's fun at first, but
of course.
Five times, it might still be fun. 10 times, yeah. You just got to optimize for your situation, right? That's what it's all about.
So to answer Kenny's question, that's a pretty basic requirement, and ultrasonic transducer amplifier. Really, there's probably 100 op amps on the market that could probably do it. So,
yeah, we did not look, so we can't say as much. But
no, but there's a lot. It's not a very like you didn't tell us about noise floor or anything else. But when you're talking about ultrasonic transducers, it's like what you want to test it. You're measuring a distance. Is that the thing? It's going to be near enough.
Yeah,
there's not really large spec requirements on your op amp there, I'm guessing.
If you are interested in op amps, there was this really cool video that I forget who posted it. I think someone on Facebook posted it, but of actually Harold Black, the guy that invented negative feedback, talking about negative feedback. It was crazy.
Right.
So it's this video from the 80s, and he's old by this point, but he's talking about actually like the moment when the inspiration struck him. It was actually on the ferry staring at the Statue of Liberty. And
sweet.
Yeah, it's this really cool video. And actually all of these videos from the old AT&T, like there's a lot of old Bell Lab stuff. So I'll post a link to the video.
Yeah, I'm looking through the list. I didn't know about this.
It's a cool channel.
It looks awesome.
Yeah.
All these retro videos.
There's a really good one I was watching on there of the first they did this press conference for the video phone back in the 70s, right?
Right.
And it's like it's exactly what you'd expect, right? It's totally trumped up. It's like, they call it the picture phone, right? And it's like, but it's totally a press event, right? It's like, we're breaking ground today. I'm
watching it now. It's hilarious.
Yeah, we're breaking ground today. It's like, well, yeah, I mean, they were, but it's like, it was an undefined market. And, obviously, even today, as we have smartphones in our pocket, we're not doing video chat still. So... Some of what because of AT&T, right? Because of data rates.
This is great. This is a great channel. It really is. AT&T
really cool.
Tech channel.
Yeah, we'll post a link to it.
It's just got all these old tech videos, retro tech videos. This is great.
Yeah. So
man, there goes
Dave's day. Yep.
That's okay. I don't have a real job.
Yeah. Right. Yeah. So
this is great.
Yeah. Oh, anything else
That's
for this
a gold
week?
mine, folks. No, look, we're almost 20 minutes over.
Yeah. So we will try and have T-shirts by next week. If not that week, then the week after. And
they will eventually make it.
And they will be in the store, and they will be awesome.
Yep.
Should we start saying the catchphrase as we have two different taglines that we're using. The amp hour, keep current, and then the amp hour, potentially different opinions, which are both nerdy and punny, but they look good on T-shirts. So,
yep. Well, it's not so much the slogan; it's the logo that the graphic artist has come up with. Of course.
Yeah.
Yep.
Yeah. Yeah.
So it's not really a slogan T-shirt; it's more of
no. We'll work on those
T-shirt.
after that. I have a whole list of others. If people like T-shirts, then we'll start cranking them out and having them.
Yep.
Reasonably priced sales. So, all right. Cool. We'll see you next week, Dave.
All right. Are we going to have a guest?
Yeah, sure.
Yeah, sure. Yeah, right. Send in your questions for us next week as well.
All right. See you later, man.
All right. See ya.
This episode of the Amp Hour was brought to you by Triad Semiconductor. If you need maximum flexibility in both the analog and digital realm, check out the VIA ASIC and associated VIA Designer software. Visit viadesigner.com/theamphour and enter AMP100 at registration for a free year subscription, a $500 value.